Trade Chemistry. I'm your host, Lewis.
And I'm Arrhenius.
And we're going to be teaching you all about chemistry today through several experiments.
First up, we're showing the decomposition of hydrogen peroxide into hydrogen gas and oxygen gas with potassium iodide as a catalyst.
This is soap, and I'm going to be pouring it in the bottom so that you can see the bubbles in the reaction. This is potassium iodide, and it will catalyze the reaction so that it goes faster. This is hydrogen peroxide, and it will decompose into hydrogen and oxygen.
What you just witnessed was the decomposition of hydrogen peroxide into oxygen gas and hydrogen gas. Why don't you tell them about the soap bubbles, Bronstead?
Right, so what the soap did was allow us to see the bubbles that formed in order to actually see the reaction and actually see the process that happens.
That's right, and the potassium iodide acted as the catalyst. The catalyst decreases the activation energy of a reaction and allows the reaction to proceed with more speed.
Right, it increases the rate of the reaction. As you can also see, heat was released over the course of the reaction. This means the reaction was exothermic, which explains why it got so hot.
Next up, we're going to be looking at the polarity of three different substances.
What we will see is that the polarity affects how the charged rod, which we will use, affects how it reacts with the charged rod.
Alright, so what I have here is a rod that I will charge using this raccoon fur. And in this burette I have hexane, in this one I have 1 propanol, and in this one I have water. And I'm going to see how the charged rod interacts with each of these substances.
You just witnessed the effects of a negatively charged rod on 3 different chemicals.
And to get the negative charge on the rod, we rubbed it with a raccoon pellet, and then we put it next to each stream to see what happens.
The 3 chemicals we used in this experiment were water, which is a polar substance, 1-propanol, which is a slightly polar substance, and hexane, which is a non-polar substance.
And each polar substance has molecules in which electrons spend more time in one end, which has a negative charge, and they spend less time on the other end, which has a positive charge. And each molecule is the positive end is attracted to the negative rod, which is why the streams move towards the rod.
Right, so this explains why water, a polar substance, was more attracted to the rod than 1-propanol, which was still slightly attracted to the rod, but which was more attracted to the rod than hexane, which is a non-polar substance.
And for our next experiment, we're going to be melting lithium and turning it into lithium oxide. Alright, we're going to be creating lithium oxide by first melting the lithium and then looking at the flame test. you just witnessed the synthesis of lithium oxide from lithium metal and oxygen gas.
That's right. It's also an oxidation reduction reaction because the lithium metal becomes ionized and the oxygen gas gains a negative charge.
Also, as you saw in the video, lithium is very soft, malleable, and shiny. This is because it's a group 2 metal.
Also, you notice that the flame turns red when the lithium was brought into the air intake. That's because lithium ions create a red color when in a flame.
Next up is the creation of pure carbon from glucose and concentrated sulfuric acid.
I'm going to be pouring concentrated sulfuric acid into sugar to create pure carbon. And there you have it. That was the synthesis of pure carbon, a nonmetal that was created using concentrated sulfuric acid and glucose.
The sulfuric acid in the video had a molarity of 18 molar. Because sulfuric acid is a strong acid, the hydrogen completely dissociates. So the solution had a pH of negative 1.25.
Now let's concentrate a little bit more on the actual reaction that occurred. So, as you saw, pure carbon was produced, which is black. It was a black little snake-like figure that arose from the beaker. It was pushed up because of the creation of water, which turned into steam because the reaction is exothermic. This pushed the carbon up and allowed you to see the black stuff that came out of the beaker.
Wow guys, that was so damn cool.
We hope you all learned something today.
We'll see you next week on
Let's concentrate on chemistry.
Hey, could you turn me up some more? Right there. Or maybe I could.